challenge from my recent work. So it's about the annotation of intonation data in multilingual and bilingual settings. And to introduce the challenge, so annotation of intonation is inherently language specific, and actually there's no unified framework that can be applied across language, actually. So this makes it especially problematic for the annotation of speech from multi or bilingual populations, because they often transfer like some certain intonational patterns from one language into the other, or maybe they also create some new patterns, let's say. And the question is now, like, how can we address this? But let's look first at the status quo of intonation annotation. So what has been often used in this kind of research is the tone and break indices system. So the TOBI system, which was originally developed for English and adapted for, I hope you don't hear my daughter in the background. Sorry for this, if yes. So, and there are a lot of numeral adaptations for other languages. So for instance, we have G-TOBI for German, or TOBI Italian, or TOBIT for Italian, and SP-TOBI for Spanish. All these adaptations, and also the original version for English, has been developed typically based on monolingual speech samples. Or at most, they also consider kind of regional variation. So for instance, for Spanish, there's a very nice volume by Prieto and Rosiano. And also De La Rosarie considers regional variation, for instance, not only for French in France, but also French spoken in Switzerland and other areas. And today we want to look at this kind of differences in polar questions and comparing the labels for these polar questions from G-TOBI and for German and TOBIT for Italian. And polar questions are questions which can be answered by yes or no, or also maybe. And here in one, you can see an example for this. So did Mary eat the cake? Or like in one for Italian, Maria ha mangiato la torta. And for German polar questions, we find rising boundary tones mostly. So either more a shallow rise or falling rising boundary tone, L minus H%, or what is actually more common is the upstep one, so H minus upstep H%. But in Italian, we have kind of a shallow rise expressed by another label, L exclamation mark or LH%. And and in Italian, we have to say, and this is what we see here in gray, is that we have a lot of regional variation, and especially in the southern varieties, we also find low boundary tones, L%, or falling ones, HL%. And what is what concerns the excursion for this rising boundary tone, we have differences in the two languages here, because for German, we find an upstepped version. So this means that the rise is really steep and high in comparison to Italian, also here expressed by the semitone. So here we have just kind of a rise, how I described. The two languages also differ with respect to the nuclear pitch accents, which is usually low in German. So here expressed by L, but rather falling in Italian, so H plus L star, or it can also be rising in some Italian varieties. And now let's have a look what we did in our paper, in our investigation. So we looked at bilingual population. So we looked at heritage speakers of Italian living in Germany. And these are also adult speakers. And in the first step, we just compared the two languages. And in the second step, we did a comparison of groups. So we looked at heritage speakers and monolinguals. And let's first look at the language comparison. So this means we look at the Italian and German of one speaker, so of one speaker group of this bilingual. And here we decided, especially for the boundary tones, to use language-independent labels. So this means for rising boundary tones that we use for the two German versions, L minus H% and H minus upstep H%, and the two Italian ones, L exclamation mark H% and L H%, just the rise. So we just describe them as a rise for the language comparison because it's very different, because you see it's the labels different. And we also looked at a more phonetic approach, let's say, and we looked at pitch excursion for this. So this means, yeah, that we just considered like really the contour, what we found, yeah, for these kind of rises. Let's move on to the group comparison. And here it was kind of easier. Of course, if you are just looking at the Italian of the two different groups, we could use the language-specific TOBI systems, but this was not enough, obviously, because I already mentioned the transfer that this kind of population sometimes show. And in this case, we also used a nuclear pitch accent from German for the annotation of the Italian data, because when we looked at it, we found some very typical German patterns, because German is the majority and also mostly the dominant language. And we found it also in Italian. And in Italian, we did, this is actually not existent according to Chili Fivela, at least, because it's not used for a nuclear pitch accents, but rather for post-focal accents, let's say. And in combination with the TOBI system, we also used here again the phonetic approach. We looked at the pitch excursion for rising boundary tones. So what worked well here? So I think the simplification of labels was quite easy, because once you have annotated with the TOBI system, you can simply recode and divide into high, low, and rise, because we not only looked at rising, because we also found high plateaus or low plateaus or falling contours, as you have seen in the introduction for the two systems, yeah, for the two languages. And of course, this creates a high comparability between the two languages. And then I think it was also quite easy to adapt the label of one language system into the other, as it was the case for the L star, from German into Italian for the nuclear pitch accent. And the phonetic measurement was also quite easy. So this was actually easily done, as you could also do it with other populations. So, and I think it's also nice because the measurement of a pitch excursion is also more objective in comparison to the label, because it sometimes depends, or it's more subjective, let's say. So what we thought is still challenging. So like, if we do the simplification, of course, it's not that precise anymore. Yeah, so we only have like 3 categories and not the different labels anymore. So we lose some information at that point. And then we had, and then we also thought sometimes it was very difficult to differentiate between different TOBI labels. So here I brought you another example, especially for the bilingual data, because sometimes it was very hard to differentiate between a low nuclear pitch accent and a very shallow fall, because sometimes bilingual populations also create hybrid categories. So, and how to address them. So this is the question here. And yeah, then there's also like, it also is like kind of bridging to the question for the open discussion. But the question is also like, what do this phonetic measures, like kind of time course analysis, for instance, or like this measurement of pitch excursion, imply for the phonological categories? So is there a threshold for the existence of different categories, and where like to like, yeah, define, or how to define this threshold? So yeah, and this leads me to the questions that we brought for today. So first, has an alternative approach capable of addressing this problem already been developed? And are we annotating phonological categories or phonetic variation? And third, kind of purely phonetic approach, kind of just measuring time course analysis, or like doing just time course analysis, measuring pitch excursion, etc. Solve this problem of category annotation entirely. And fourth, which approach would be suitable for handling trilingual or multilingual data, because we do not have only two different systems, maybe we have 3 or 4, and how, yeah, to model this kind of interaction between the different languages. Yeah, that's it. Thank you very much for being here. And now I'm looking forward to discuss these questions and also like the topic with you. I'm very curious about your ideas and what maybe you have already done.